Hi guys, welcome to HackCloud Machine Learning. Woo! If you want to, QR codes, slides, and also mini hack. Woo! This Saturday, sign up here. And also, there's candy. We only have milk duds. All right, so you can skip that slide. We'll start off with what is machine learning? Just like a brief introduction. I have no idea. I think there's supposed to be more here. But pretty much machine learning, we're just trying to develop some sort of algorithm and get that algorithm to recognize patterns in data. Machine learning is very helpful for especially big data applications when you have a large data set that you need to, recognize patterns in, because with a smaller data set, you can usually like graph it and see it with like your eyeballs or something. Not all the time, but this is sort of, I guess, an example of traditional programming versus machine learning programming. I guess it's like pseudocode. And just like importance, again, big data, every industry pretty much uses ML at this point, and it makes a lot of money. So here are some machine learning applications, object recognition, especially with like visual machine learning. That's done a lot, especially like companies like Tesla with their cool and awesome self-driving cars, weather prediction, product recognition. You can read ChatGPT exists. And why is cloud computing good for this? It's good because your laptop as a college student sucks. And if you want to process big data with your laptop, you can. So we use the cloud because like companies like Amazon, Google, they have big servers that are very powerful at processing big data, and you can use their hardware if you use the cloud. And that's pretty much the biggest pro of using the cloud for ML. Yeah, and this is just sort of the ML pipeline, sort of broken down. You get your data from some source, you do some data wrangling, which is pretty much just pre-processing your data. This stuff is actually like very, very important, because if you have good data and it's readable and your ML model is able to train well off of your data, you'll get better results. And you can build like your ML model, which we'll be showcasing today, as well as training it. And pretty much training is, it recognizes patterns, then you can deploy it in some form or fashion. I think ChatGPT is the best example, where it's like this user interface, you can ask questions and it will produce a response. So what is a model? Ooh, pretty much what a model is it's like, I don't know why it says a file, but more like a program or some sort of mathematical representation that can just like recognize a pattern. I think the most simple form of this is like a line of best fit. So y equals mx plus b. Of course, that is not the entirety of ML. It's just a very simplified version of like what linear regression is. And pretty much you can train it over a data set and you get an algorithm out or something of the sort, some sort of math that sort of guides how you're going to learn, how you're going to predict and perform on a data set where maybe you don't have like, you want to extrapolate the data pretty much. Yeah. So supervised and unsupervised learning. This isn't entirely relevant to this presentation, But supervised is pretty much when you have training data, and that training data has like sort of like maybe it's classified. Say we have a data set which we'll be working with of like tumor data, and we want to know, is this tumor like benign or malignant? Malignant is very bad. We can label that based on other features of, say, the tumor. And that's what a supervised model is. We give data that already has those labeled versus unsupervised, which is we don't label those, and our machine learning model is pretty much just going to recognize patterns and produce some sort of output telling us about these patterns. An example is the Netflix recommendation engine. We're going to be going over two models today. One is a regression model. The second is a classification model, more specifically binary classification model. Regression can come in many forms. The most common is probably logistic regression. Also linear regression, very common. It's sort of like, you can see this math equation, very basic. We have one or two variables and a dependent variable, which is our estimated target. And pretty much we're trying to predict this estimated target based on here, our age and income. And the machine learning model would allow us to like extrapolate this plot and see, based on age and income, maybe we don't tell it what the target is and it will generate that. In a supervised model, a classification model is pretty much the same thing, except we're going to do classification. So like a 1 or a 0. Is this true or is this not true? That's binary classification. Of course, there are other classification models, but then you get into more complicated networks that are like neural networks. That's what it's called, where you have a bunch of nodes and they're all related and you're doing classification based off that. But in this case, we're just going to be covering binary classification today. So one thing's true, another thing's true, malignant, benign, awesome. And I have another slide on this, but this is pretty much the AWS stack. They have tons of services, as well as like frameworks for doing machine learning. So TensorFlow, PyTorch, Keras, some of the most common, I would say. And then just their like underlying infrastructure, pretty much S3 and basic storage and all the hardware and all that good stuff. But now it's SageMaker time. We get to do a demo, and I'll just show you how to build and train a model using low code. We're not ACM AI, so I'm going to do low code because I'd rather showcase like what AWS can do with SageMaker specifically, rather than show you a Jupyter notebook with a bunch of Python code, because I cannot explain all that Python code in an hour. So just to start off, why is SageMaker? There's just a bunch of bullet points. It's a fully managed service, so it automates a lot of stuff for you, which you'll see when we use AutoML. There's also AWS Autopilot. It pretty much does everything for you. It's very nice, very low code. Obviously not for every sort of situation. If you need like a custom model or custom data set, statistics is very dependent on that. So, you know, of course, you would have to write your own Python code, use some libraries, pandas, TensorFlow, stuff like that to generate your own model. But for the most part, it has a lot of common models. It has Jupyter notebooks integrated. So a lot of people who do data science and ML, Jupyter notebooks are like your go-to for documenting and honestly just testing things. It has model tuning, so it does automated hyperparameter tuning. If you don't know what that is, don't worry too much. It pretty much just makes the AWS model better and more accurate. And it's also integrated with the AWS ecosystem. This can be a good or a bad thing, depending on how much you like AWS, but services like S3 are very helpful, as well as just being in a cloud environment. And I will also go over some cons, just so we have like the big picture. It has a high learning curve because you're not only learning ML and how to use all these libraries, Python, you're also learning how to use the AWS environment. which can be very funky and convoluted at times. The SageMaker Studio is the IDE we'll be using. It's like an in-browser thing that Amazon developed for using their ML service. And let's just say it looks very nice. There are a lot of good features that are straightforward, but there are some things that are just part of the interface that don't make sense. Cost. This can be a positive because you don't have to buy millions of dollars of servers, but it can also become expensive if it's running in the background. And after the demo, I'll go over how to like clean up all of your tests so that it doesn't charge you, because your SageMaker service will run until you stop it. It's also a con. It's limited to AWS. This is also linked to troubleshooting. We abstract like AWS's like infrastructure. So if there's a problem with their infrastructure or something that they developed, you can't really do anything about it other than like contact their support and be like, hey, there's a problem, and then not get a response or get a response. And also you just lack full control. For more advanced users, but this is the other diagram of the AWS ML stack. The reason I have this in here is you can see that SageMaker isn't the only AWS service for ML. They have tons of very specific ones, such as like Amazon Transcribe. So like you take speech and you can transcribe it to text, but they have a bunch of specific services for specific things, which is really nice. But again, it's for specific things. So if you don't need it, you kind of can't use it. But their main service is SageMaker, and then their SageMaker Studio IDE, which we will be using. So just before the demo starts, we're going to be building and training a regression model and classification model. And these data sets that I'm using are from UCI Machine Learning Repository. Here are the names. If you want the data sets, you can go to the slides and go to the repository and look them up and download them. They're both just CSV files, but yep. And just to talk a little bit more about them, the first one, this is our regression data set. It's combined cycle power plant. Pretty much there's a bunch of data points, around 10,000 for temperature, ambient pressure, relative humidity, exhaust vacuum. You don't know what those are, it does not matter. We're pretty much just trying to predict the net hourly electrical energy output of a power plant that they ran for like 6 years, and they ran it at full power, and they just were like, hey, is there any correlation? Can we predict and find a pattern with this using ML? And the second one is the breast cancer data set from Wisconsin. A smaller data set, but definitely more, I guess, applicable just on the surface. Bunch of stuff about tumors. They had a bunch of breast cancer patients, and they're trying to see, hey, based on all of these attributes, can we classify the tumor as benign or malignant? Yeah, but let's just get into the demo. No, go away. All right. So if you go to the AWS console, this is where all your good and lovely AWS services are. One of the first things we're going to want to do is just upload our data sets. So I already have them downloaded, unzipped, and you should as well. We're going to be storing these in S3 buckets. So if you go to S3, you should see that you can create a bucket. I have a bunch of these here. Make sure whatever you're doing this on, like the region, which you can see right here, you need the same region for everything. Otherwise, stuff will screw up. You shouldn't see anything here, but I've been doing some tests. I have some stuff ran already. So just make sure if you're here, you're probably on from California. But yeah, and you may not see this error. It doesn't matter. So we're going to create our bucket. I'm just going to name mine SageMaker Demo. I'm going to name it 3 because I'm pretty sure I have 2 buckets that are named 1 and 2. And then S3 buckets have to be unique, so just type a bunch of random numbers. It does not matter so long as you remember it. And then select your AWS region. I'm going to be on Oregon, just because I need a unique region for this. But other than that, you should just be able to use all default settings. Oops. And you can scroll all the way down to the bottom and just create your bucket. Awesome. So now we have our bucket. Yours should just show up independently. Mine's right here. And if you click on it and you go to upload, we're pretty much just going to upload our data sets. Very simple. We'll do this really quick. You can just hit add files and browse to them. So I have the regression data and the classification data. This is the breast cancer set. This is the power plant set. And after that, you can note the destination if you want to. Otherwise, it does not matter. And then you can just hit upload, and we should have our 2 data sets in. You should see success and 2 files, and that is all good and dandy. So now we want to create our SageMaker notebook, but first, as with everything in AWS, you will need some sort of user or role, which is using IAM for access management. Go to IAM and roles on the left side. And you should not have all these roles, but we're pretty much going to be making this SageMaker full access role. So if you hit create role, and you hit down here, you can select a use case. We are going to be using SageMaker. So select SageMaker and highlight this SageMaker execution. We just want to give full perms or permissions, and it's an AWS service, so we can just hit next. And you can see the SageMaker full access permission on this role that we'll be assigning. You can just hit next. Woo. And for the role name, I'll just name this SageMaker full access role. Again, 3 because I have 2 other roles. So you can just name it that, but there's like a default description. We don't need to worry about any of this, and we can just create the role. And we'll load for a little bit, and then you should see your role in here. Mine's right here. And if you click on that role and go back to it, we just want to make sure we don't have any errors down the line when we're trying to access our data from S3. So if you attach another policy with that drop down right there, we'll look up S3. And you should see Amazon S3 full access right here at the top, and we'll add this permission. And you should see it there. And after that, we're all good to go with our SageMaker role, so we don't have to worry about any of this like initial setup, and we can get into the fun ML part. So we're going to go to SageMaker, and you should see this cool and awesome startup screen. If you want, you can just hit get started. You can see the first thing here is configure a role. We just did that. We're going to configure our SageMaker domain so that we can open up our SageMaker Studio IDE and actually build and train our models. So we'll just do quick setup SageMaker domain. In the name for domain name, you can just do whatever you want. I'm going to name it SageMaker Demo 3. And for the user profile, you can do whatever you want. So I'm just going to put my name. And just hit submit, and this should set up our SageMaker domain. And now this does take a little bit. But pretty much after this is done, we can open SageMaker Studio, and we'll have our IDE open, and we can use something called AutoML. Now, loading this domain does take a little while. Opening SageMaker Studio for the first time also takes a while, and training and building your models also takes a very long time. Now for this, it's like 10 minutes, which in the grand scheme of things is not that long, but we don't have big data sets. However, for the sake of this demo, I don't want you to wait 10 minutes here while it loads the domain, so I've already done this. Just to note, once the domain is created, you should just see it in this list. You can either click on the name or there's a drop-down on the right where you can just hit it and it'll say go to Studio, and you can open up SageMaker Studio. So I messed this up last time, but I'm just going to share my other screen or other browser, but right here you can see that, or if I go back, we have SageMaker Demo. The domain has been magically created. If you go into your SageMaker Demo, you can see the user you made. The other one, it was even Andy, does not matter. And if you go over here to launch, you can open up SageMaker Studio. And again, on the first startup of this IDE, it takes a decent bit to load. But after it's open, you won't see these tabs. You'll just see this home. And this is what SageMaker Studio IDE looks like. You can see here, initially, we have a bunch of different buttons. You can have a Jupyter notebook in this. There's a link to the documentation and some other good stuff. If you go over to the data dropdown right here, there is this thing called the data wrangler. If you remember, I talked about this in our machine learning sort of pipeline. You can make a flow in here. If I just go to hit import data, this isn't really important to the demo, but this data wrangler is a very neat tool. It automates a lot of the tedious stuff to do with data wrangling, such as like splitting your data set into a test and a training set. Of course, AutoML, which is what we'll be doing, does it automatically, so it doesn't even matter. But if you go to Amazon S3, there's also other sources of data that you can get from, and Amazon themselves have example data that you can pull from. You can go and select your S3 bucket. Mine was SageMaker Demo 3. You shouldn't see as much as this if you don't have any S3 buckets. But if you just hit that, you can see your two data sets. So say I want to import my regression data set, I can just hit import, and it should pull up the data set. Sometimes this takes a long time for a reason, and sometimes it doesn't. But here you can see the data set. So you can see our header, AT, B, AP. I went over those in the slides. It's pretty much just like ambient temperature, vacuum, and some other things to do with the power plant that were measured. And our dependent variable here, which is, we could call our target, what we want to predict, is the net hourly electrical energy output. But that's this column. So if we go back, there's this little arrow. I don't know why they don't bring this up first, but if we go back to our data flow, there's sort of this like chart or map. You can zoom in. Yeah. Whoa, our chart, our map. So you can see that we have our data source here, which is our CSV. And it already has a step in the process, which is assigning data types. It assigned everything to a float, which is fine and dandy. Say we want to do something to our data, like we want to split it into a training and test set, and maybe even a validation set or something else. You can click this little plus, add transform, and then I will have to zoom out because the UI is a little funky, but you can go here, add step on the right, and there's tons and tons of different transforms. If you just scroll down here, the one that if you wanted to split it, if you just type split data, and you can split into a training and test set. They already have it pre-populated with the name, and can do 80-20, 70-30. Those are some common splits. As long as it adds up to 1, you can go here, add another split, like a validation set or something of the sort, and readjust. Also, this is on a randomized split, but based on your data, you might want to prep it differently. So a lot of other splits like ordered, stratified, split by key. I won't really be going over this, but just for data wrangling, this is super helpful, especially it doesn't automatically, you don't have to code anything in Python with pandas, data frames, or whatnot. You can just hit this and output it. And yeah, that was just a little bit of a showcase of data wrangler. But now we'll get into the actual ML portion of this. So you can just go ahead and close this. We weren't really going to do anything with it. You can play around with splitting the data sets if you want to. But now we will build our first model. So the first model we're going to be building, again, is the regression model. I already have them generated, but I'll show you how to generate them for our power plant data set. So if we just go to here, create an auto ML experiment, the top right. This is AWS Autopilot. It pretty much does everything for you, which is very nice. Of course, one of the cons is that it's very limited. So you can use Jupyter Notebooks, you can use Python and different kernels for dependencies. But for this very low code, Autopilot can be good for a lot of data sets. So our experiment name, I will just name this SageMaker Demo 3. Again, you can name it whatever you want. And our input data, we're going to browse. This is my input data, whatever you called yours when we made our S3 bucket. And our first one we'll make is the regression data set. So if you just go ahead and select that CSV, we don't care about it being a manifest file. But also here, auto split data, this is where it does the sort of data wrangling for us. If you go to that little question mark, I don't know how readable that is, but it says automatically uses 80% of your data for training, 20% for testing, validation. You can also select no and do custom split, which is very useful, but we'll just leave it on auto. There's also like output location. You can set that if you want. I'll just leave it as yes. And we can go to next. This is where we'll select our target, our dependent variable, the thing that we want to predict with our model, which in this case is PE. That's again our net hourly electrical energy output of the power plant. You can also do weighting. We're not going to deal with any like weights, biases, hyperparameters. If you want to, you can get into some of that stuff, but we'll just sort of leave it on auto. And down here, if I zoom in, you can see the features of your data set. So we have our 4 variables. Data type, you can select it or you can leave it on auto. This is pretty much doing that like workflow that we did earlier with the data wrangler, but for us. And you can see that it's set PE to our target, which is what we want. So if we go to next, this is where you can select your training method or what model we're going to use. AWS has a decent amount of models built in, and it'll pretty much just, if you leave it on auto, test it against a bunch of different models and ensembles of models and do a little bit of hyperparameter tuning, I believe. I believe it uses something called Bayesian search theory to find like the best ensemble or not. I do not know much about that. But you can also select ensemble, and there's a bunch of built-in models like XGBoost. I've heard a lot about linear random forest, so you can select these. And yeah, if you want to, there's also hyperparameter optimization here that you can select fewer models, but this can give you a higher degree of accuracy. But we'll just leave it on auto because we're lazy and we love not doing anything. Autopilot. So if we go to next, this is like some deployment settings. It'll create an endpoint for you if you want to use your model in an application for doing like predictions or something. I won't be going over like using your model externally here, but we do need to create an endpoint. So we'll just name ours SageMaker endpoints and the date, which is what they recommend. And here it's a little bit small, but we can select our machine learning problem type. Again, this is our regression set, so we can select regression. If you leave it on auto, it will probably go with regression anyways, but we have regression. So after you select this will also bring up like what's our objective metric, what makes our selection of models the best model for this data set when it goes over like ensembles and tuning. We're going to be using mean standard error. This is just statistic stuff. This is pretty much like if it predicts something, how far away is that to the actual value? And if this is higher, well, more error is worse. If it's lower, it's probably a better model. So we'll leave this as our metric. There's also other metrics. If you take in statistics, R squared, RMSE, but we'll just go to next. You can see all of your different options. And yeah, we can just hit create experiment in the bottom right. And we're going to generate a machine learning model with no code written on our behalf at least. Again, there's a degree of customization to this. It's limited to AWS's built-in models. Again, this isn't great for all data sets. You have to be sort of knowledgeable. No, generate. Okay. So my S3 buckets are weird with the regions. It does not matter. If you hit create experiment, it will bring up like just like AWS Autopilot is generating. It'll load for like 15 minutes for the sake of the demo. I have already generated all of this stuff, so you can just hit create experiment and wait, and it will generate eventually. And it will bring up a screen that if I launch another instance of Studio, it will bring up something that looks like this. It loads. Lots of loading. Ooh. But yeah, if we just go down here to experiments, should load. So I ran this before. Regression. You can see your experiments here and 10 times. So it tried 10 different like ensembles or different models. But if we go back to Auto ML, this is a better visualization. This is what should come up after it just runs through that. And you can see that it went with a bunch of different ensembles of models, and it chose the best one based on our objective, mean squared error. Again, lowest is best, so it came up with 7. And if we go into this weighted ensemble, we can see a lot of different metrics, which is very nice. We don't have to do visualization for a lot of like statistics on how good did our model do, what was our model most based on. So if you go down to model explainability, this doesn't actually tell you anything about how accurate the model is. So just note that it's important to like not go in blindly. Machine learning statistics very important. But we can see here that AT, which is temperature, seem to be weighted very high. So it used that to predict higher, or at least you could say that there's a high correlation between ambient temperature and the net hourly electrical output. You can print this if you download feature reports, but the cooler part of this is not the explainability, but the performance of your model. So if we go over to this tab, it generates a bunch of stuff for you. This kind of isn't the greatest UI for this, so you can go here and download a PDF of this. And if we just open the PDF, this is pretty cool. It has like actual explanations for what each plot specifically is, as well as like explanation. So if I zoom in, because I know this is a little bit small, and it'll show you your metric table. Again, how good is it? We can see our R squared is pretty high. and MSC is the best out of the models. But if we go down to our actual versus predicted plot, you can see that this data set, our predictions, were pretty close to our actual values. Of course, we have like a few outliers if you look right here, but the mean squared error is indicative of that, as well as like R-squared value and whatnot. And again, there's like little paragraphs that explain what each plot is. There's a residual plot right here. This is just like sort of stuff for your statistics, a histogram. We have a cool and awesome bell curve around 0. So that means that our data or our model wasn't doing like anything weird. It wasn't producing any like biases towards one end, like over predicting or under predicting anything. Which I believe it says here. But yeah, for at least a regression model, this is the output you get regarding like how well did your model do, which in my opinion is very cool. A lot of like boilerplate code that you would have to write with Matplotlib, whatever you're using, pandas does it for you. And you can repeat this process using AutoML with your classification. I won't go through that just for the sake of time, but only difference would be you select that data set instead, and you do binary classification, which if you leave it on auto, it will probably know that. So our second data set was on breast cancer patients and whether or not their tumors were benign or malignant. And I've already run this. So if you go Autopilot and we go to classification demo, we can also look at some of the output for this. So in this case, the objective was accuracy. So how well did we predict? In this case, 2 was our benign tumor, 4 was our malignant tumor. How well did we do with this? You can see our accuracy for our best model is pretty high, 0.971 right here. There's also other values. I know it's a little bit hard to see, but like AWC precision, not AUC. But if we click on our model, you also get feature importance and some of this explainability. Again, this has nothing to do with how well your model did, but it can be useful. So if we go to performance, and again, download the PDF, the classification report is, in my opinion, cooler than the regression report. You get to see a lot more in terms of how well did your model do. We have a bunch of stats. We based ours on accuracy, 0.97, very good. But you also get something like a confusion matrix, which if you don't know what this is, it's pretty much showing you false positives, false negatives. So if our actual label here, I know it's very hard to see, but there's a 2 here, a 4 here, 2, 4, because 2 is benign, 4 malignant. We can see here, like if the actual tumor was benign, we had 86 ones that were true, because this is predicted, this is what is actual. So we had 86 that were true, and 1 false positive for malignant, and then the other case, 3 that were false positive for benign. So overall, our data set did pretty good. Our model did pretty good on our data set with 4 inaccuracies. So I can tell you something. There's also other stuff like the ROC curve, precision recall curve. I'm not too familiar with all of the plots, but also a gain curve, very useful. But just a bunch of other data about how your model did. Very cool output. Explains everything. So if you don't know, let's say like what a confusion matrix is, again, you get sort of an explanation. But other than that, that's pretty much the demo and our workshop for today. Again, it was very simple, no code, not even low code, because AWS Autopilot is pretty cool if you want to run on a simpler data set, such as like, we had a linear regression one and a binary classification one. Now, if you want to do something like a neural network, yes, you have to create your own model and do all the Python and whatnot, but there are good libraries that are integrated, and I believe there's plugins for stuff like TensorFlow, PyTorch, very useful libraries and tools for doing that sort of thing. So I'm just going to go back to the slides here, but yeah, here's a feedback form you can fill out if you want to, so we can potentially have food at our next workshop, which is Datasets. And there's some resources I found useful. It's just two. One is the SageMaker documentation, and the other is, ironically, Google for Developers. They have a very good crash course on ML. It explains a lot of the basics, like regression, classification. And yeah, thanks for your time. Again, next week, the 25th at 7:30, we'll have our next workshop and our final one. So yeah, thank you.